In this video, I'll show you how to solve the ALEKS problem called predicting how molecular speed distribution changes with temperature and molar mass. To help you solve this problem, you are probably going to want to have a periodic table handy. I'm just looking at the periodic table that is present in ALEKS. So this problem is giving us 6 total different samples of gases, although they are kind of sorted into 2 groups. ABC is one group, and that's going to correspond to the first graph, and then DEF is the second group, it's going to correspond to the second graph. And what you're being asked to do is find the graph that corresponds to the correct speed distribution for each of these 3 gases. And you can drag your slider around to see the different speeds. Now this problem, or the different shapes of the graph. This problem is a lot easier than it probably initially appears. First thing I want to do is just talk a little bit about the trend for the speed of a particular gas. That is directly proportional to the temperature of the gas. So as the temperature of the gas increases, the speed of the gas is going to increase as well. And we can use that relationship to help us identify or distinguish samples A, B, and C. It's not going to work for samples D, E, and F because notice they're all at the same temperature. But these 3 samples, we can rank them just simply based on their temperature. The one that has the highest temperature is going to have the highest speed. So this is the gas that has the highest temperature. C, I'm just going to make a note down here, is the fastest or highest speed. And then my B will be next, and then A is the slowest. So it'll go C, B, and A is the slowest. And then what you're going to want to do is drag through these different graphs, and you're going to look for the one that has gas C as having the highest speed, meaning that its peak. So you're going to be focusing on the peaks of each of these graphs. There's the peaks, this is the peak for B, this is the peak for C, and this is the peak for A. So this particular graph is telling us that gas A has the highest speed and gas B has the slowest speed, and that's not what we're predicting. We're predicting C has the highest. So you're going to drag the slider around until you find a graph that has, I'm just going to kind of fix this, C as the fastest gas, meaning that the high point of the graph is the furthest to the right. And then B would be our slowest, or medium, and A is our slowest gas. And you're just, like I said, you're just going to drag the sliders through until you find one that works. Now for the other sample of 3 gases, D, E, and F, because all of these are at the same temperature, obviously we're not going to be able to use this relationship here, so we're going to need a different relationship. The speed is inversely proportional to the mass of the gas, which is why the periodic table is going to come in handy. So the faster the gas, faster gases are typically smaller gases, smaller atoms. The smaller the atom is, the faster it is moving as long as everything is at the same temperature. So for these, we're going to be ranking these gases according to their size, which we'll get from the periodic table. We have krypton, we have argon, and we have neon. So since neon is the slowest, that means that it is going to be the fastest, and our neon is sample F, and then argon is going to be the next one, and then krypton, because it is the heaviest, that one is going to be the slowest. Krypton is sample D. E is in the middle. So again, same kind of thing. We're going to drag the slider through, and we're looking for a sample of gas that has F as the fastest gas and D as the slowest gas. So I could fix this. F would be the fastest, D would be the slowest, E would be the one in the middle. Now, you are going to notice as you drag this slider through, you're going to notice that there are different shapes to these graphs. So you can clearly see that these 2 graphs don't have the same shapes to them. These are all same height peak, where these ones have different height peaks. So there's other shapes as well. And what I saw when I was looking through the different versions of this problem, that you really don't need to worry about that. I would only find one answer that had the gases ordered correctly based on their temperature or their mass. That said, if you do run into a situation where you have more than one option, so for example, if there was more than one option that had the gases C, B, and A in this particular order, this shape right here is the normal shape that I would always go with. So if you see this as one of the options and the gases are all in the correct order, then go with this particular shape.